Hey, good morning, good afternoon, or good evening, class. How you guys doing? I hope you guys are holding up and doing well here. So today we're going to continue our work with solving systems of equations. And so we're going to take a look at a second way to solve these systems algebraically. So this method is, later on we'll call it the elimination method. But I just want to take a look at why sometimes it's very helpful to know another method. So if I take a look at this system here, it says solve this system using the substitution method. Okay, we can do that. So if I look at my equations, 2x plus 3y equals 7, 5x plus 4y equals 14. Wowzers, okay? We don't have an x or y all by itself. So my initial thought is, let me see if I can get x by itself. So the first thing I'm going to do is I'm going to take this 3y and move it to the other side and subtract 3y from the both sides. So I get 2x equals 7 minus 3y. Okay? Divide both sides by 2, so that means I divide everything by 2. So when I do that, I have x equals, look at this, 7 halves minus 3 halves y. Ugh. Okay, now I know it's just like, oh my goodness, I have fractions. Great, I got to deal with fractions. Now some of you might be saying, okay, this one's, I could go like 3.5 minus 1.5y and work with decimals. I'll tell you right now, it's already starting to get messy. If this was like in thirds, you'd have like 0.3 repeating. Ooh, not fun to deal with. You can already start to see that this is going to be a little more challenging. But I can still technically do it. I plug it in for x right there. Okay, so if I do that, I'm going to write that right over here. So I have 5. Replace x with what it equals. 3.5 minus 1.5y plus 4y equals 14. Okay, so now let's distribute. So, wow, 5 times 3.5, 17.5. That's 17.5 minus, so if I go 5 times 1.5, I just know that it's a negative 7.5y plus 4y equals 14. Ooh, dealing with all these decimals and stuff. So I'm going to subtract 17.5 from both sides. Okay. So when I do, these cross out. Okay. Now I can, when I do, combine these, 14 minus 17.5 is negative 3.5. Combine these two together, so negative 7.5 plus 4 is negative 3.5. So this is negative 3.5y. So I divide by negative 3.5, divide by negative 3.5. When they're the same, lo and behold, all that work to get y equals 1. So now, at least what's nice is I can plug it in right there to get x. X equals 3.5 minus 1.5 times 1. Well, that's just 3.5 minus 1.5. $3.50 minus $1.50 is just $2. Hey, we got the answer. The answer is 2, 1. All right, double check. 2 times, and I can check. 2 times 2 plus 3 times 1. Does that equal 7? Well, 4 plus 3, that is 7. Check. Do a quick check on the other. 5 times 2 plus 4 times 1. Does that equal 14? Well, 5 times 2 is 10. 4 times 1 is 4. 10 plus 4 is 14. Check. So I know my answer is right. Wow. I got to catch my breath for half a second. That took a long time. I had to deal with fractions and decimals. Yuck. Is there a way that I can maybe avoid that? Absolutely. And this method is called, okay, We like to call this method the elimination method. Okay? So, how can we solve doing the elimination method? Well, in order for the elimination method to work, and it can be challenging at times, is you want to get both variables, x and y, on the same side of the equal sign. So like if you look at the one at top, okay, notice how x were lined up together, y was lined up together, and they equaled the number. You got to get it to look exactly like this, okay, for the process to work, right? So like in this system down here, notice how the x's are on the same side, the y's are on the same side. So all the variables on the same side with just the numbers on the other side. So now, step 2, this is the trickiest part. Multiply one or both equations by a number to result in the two equations containing opposite terms. Okay? You just have to decide, do you want x to be the same or do you want y to be the same? Or I apologize. Do you want x to be opposite in numbers or do you want y to be opposite in numbers? So when I talk about opposites, that's like, when we're talking about opposites, that's like 6 and negative 6 or 2 and negative 2. Okay? The reason why we want opposites is when we add those together, when we add these two numbers together, they equal 0. When you add them together, whoops, you get, not 10, 0. Okay? So what's happening is we're just going to change the appearance of an equation. And you can do that. If I have this equation, x plus y equals 5, if I multiply everything by 2, it's exactly the same equation. It just looks different. If I multiplied everything up top by negative 3, it's actually the same equation. It just looks different. Okay? That's why when we were doing, for instance, graphing, the equations would look different. And like for this, if we were trying to get y by itself, we're going to get back the original equation. Okay? So now, once they're opposites, step 3 is to add them together, eliminate a variable. Step 4, solve for the remaining equation, because when you eliminate a variable, you're down to 1. So then in step 4, you solve that remaining equation. Then you've gotten either x or y. You figured out half of it, plug it back in, and solve for the other variable. And of course, step 6 technically is to check it. Don't forget to check. It's easy to forget to do that step. All right, so to show you how this works, and I think seeing several examples helps the process. So when I look at this and I analyze, I look, oh, 3 and x, aren't this opposites? 5 and negative 2, they're not opposite numbers. So what I can do is I can think about, can I multiply one equation or another equation such that they're opposites numbers? So what I think about is, 3x, I would love to add negative 3x to it. Well, I could take this equation and make that negative 3x by simply multiplying the whole equation by negative 3. So I'm going to do that over here. So I have negative 3x now. Negative 3 times negative 2. So I have to distribute to everything. So plus 6y. Negative 3x times 6 is negative 18. Now the thing I can do is just take this equation and copy it over. 3x plus 5y equals 7. So now, since they're opposites, what I can then do is step 3 now here is add the equations together. The x's cross out. 5y and 6y make 11y. 7 and negative 18 make negative 11. Now I can divide by 11. Look at that. Y equals negative 1. Just like that. That was a whole heck of a lot easier. No fractions, and I just got y by itself. Now I'm not done. I have to take this back in and plug it into one of the two equations. You decide. I'm thinking of plugging it in the first one since x is kind of by itself here. So I go x minus 2 times negative 1 equals 6. Okay, sorry for that little dot. That doesn't mean anything. x, negative 2 times negative 1 is positive 2, equals 6. Subtract 2, x equals 4. So now, I know these two numbers work for this bottom equation, but I should check it in the top equation just to make sure. So I'm going to come over here and check. So 3, x is 4, plus 5 times y is negative 1. This has to equal 7. 3 times 4 is 12. 5 times negative 1 is minus 5. Does 12 minus 5 equal 7? Absolutely, check. So my answers here I know are correct. Sweet. Just like that, first page of notes done. So let's go to the second page and take a look at these two problems. So just like substitution, excuse me, you can get no solutions and infinitely many solutions when solving systems using the elimination method. So let me show you what happens here. Okay, so when I look at the first one, I'm thinking to myself, right now they're not opposites of each other, but boy, if I took this first equation and times it by 3, 3 times 2 makes a positive 6, which is the opposite of negative 6. So I'm going to distribute 3 to all of these, and I'm actually just going to write it right underneath. So 6x minus 9y equals 21. So now, the next step would be to add those equations together. Watch what happens. 0. 0. So 0 plus 0. This crosses out equals 0. Does 0 equal 0? Absolutely. That is true. So if everything cancels out, that means they are the same equation. So if they are the same equation, that means we have infinitely many solutions. Sweet. All right, let's take a look at the second example. 4 does go into 8. It goes into 8 2 times. So if I can multiply this equation by negative 2, it would be opposite. So again, distribute. So negative 2 times 4 is negative 8. Negative 2 times negative 3 makes positive 6. I have 6y. Negative 2 times 11, negative 22. You guys are probably starting to see now. Add the two equations together. So I'm adding these two equations right here together. The x's cross out, 0. The y's cross out, I get 0. The numbers don't cross out. It actually equals negative 2. Does 0 equal negative 2? Absolutely not. This is a false statement. This means you have no solution. And if you have no solution, we like to say, that these lines are parallel lines. I almost started writing infinitely many solutions. Mr. Bart's is kind of almost made another mistake. All right, so how can we actually solve word problems using the substitution method? I'm sorry, not substitution, elimination method. Woo! All right, Ms. Bart's probably might need to take a break after this video. All right, so to do the elimination method, it's just like doing the problems that we did before, except we're just going to solve it. I actually find the elimination method's actually sometimes easier to use when solving word problems. So let's do the steps like we've done before. We're going to define our variables, write a system, and then solve it using this method. So here it says at Amy's Amusement Park, tickets sell for $24.50 and adult tickets for adults and $16.50 for children. On Sunday, the amusement park made $6,405 from selling 330 tickets. How many of each kind of ticket were sold? How many of each kind of ticket? So I had two types of tickets. X is going to be the number of adult tickets. And Y is going to be the number of children tickets. And technically, I should be saying sold. All right, so now I need to write a system of equations. So one is going to deal with the total number of tickets sold. So I know the number of adult tickets, X, plus the number of children tickets, Y. Those combined together have to add up and equal 330. Now the other one deals with the money. So for the second equation, I get $24.50 for every adult ticket I sell. I'm going to multiply that by X because I don't know how many I'm selling. Plus $16.50 times every child ticket. That has to, so that's coming right here. So that has to add up to and equal $6,405. All right, so I have my system of equations. So now I'm going to solve it algebraically. So what's nice about this is I just have to decide, do I want to get rid of X or Y? I've been kind of in a theme of X's, so I'm going to just change it up. I'm going to take this equation and get my Y's to cancel. So I'm going to multiply by negative 1650. You could easily multiply by negative 2450 and solve for the other variable first. That's the beauty about this, is you can do these problems so many different ways and get the same answer. Sometimes that bugs students a little bit because they're so worried that their way is not the right way. Trust yourself. See what you get for an answer. You may get the exact, hopefully you get the same answer if you do it a different way. Key is show your work. Anyway, got a little preachy there. Distribute. So I got to distribute it to all. So watch how I have this negative 1650x now minus 1650y equals, so I got to do 330 times negative 1650. Negative 5,445. Now what I can do is I can just take this equation and copy it and put it right underneath. So now, just add the equations together. So negative 1650 and 2450. If you can't trust your math here, use your calculator. Add those together. Whoa! Of course, if Mr. Bartz types it in right, he needs to make that 2450 is 8. So I have 8x. Y's cross out equals, so negative 5445 plus 6405, 960. Divide by 8, and x equals, so now I can just go divide by 8, 120. So we sold 120 adult tickets. Gotta solve for y, gotta figure out the number of children tickets we sold. Well, we know that x plus y has to equal 330. So one way I could say is 120 plus y equals 330. Subtract the 120, and y equals 0. 3 minus 2 is 1. 3 minus 1 is 2. 210 tickets. So, answer my question. We sold 120 adult and 210 student tickets. One of the things I'm just going to do is just quickly check. So one of the things I'm going to do is say, all right, 2450, whoops, helps if I type things in right, 2450 times the 120 plus the 1650 times the 210. This has to equal that revenue of $6,405, which it did. So I know my answer's right. Sweet. That's what I love about this unit. You guys are going to know whether or not you have your answers right a lot of the times. All right, so what I want you to do next is go to your pink packet, CFU packet, or go to this page, okay, in the document I sent to you, and go ahead and work on these problems here, please. I'll make sure to post a video shortly.